day 2, everything seems to be fixed and everything is working. And remember that we are live streaming, so if you have any questions, you can go ahead and raise your hand if you're in the in-person section. Otherwise, if you want to follow online on YouTube and just have put in a chat or something. For those of you that are online, you go ahead and use the chat, and we are monitoring that. Hopefully, Ryan will be here soon with a blurb on corn hacks. If not, I'd encourage you to sign up for it. It's not this weekend, but I think next weekend. It's a 24-hour hackathon. Even if you only have one language and one semester under your belt, it's still a little fun experience where you can go and you can learn something new. You can build something, not necessarily intending to win the competition. It is a competition, but it's kind of a 24-hour hackathon. There's free food. And so more information can be found at unlcornhacks.com. All right. Hopefully he'll be here to speak about that soon. One thing that I did want to bring your attention to that I was not able to show last time is something called a Gantt chart. So if you're already well organized and well disciplined, and you've got some sort of a system that works for you, whether or not that's UNL, the Canvas notification system and the due dates and stuff that are in Canvas, or if, for example, I use Gmail's task list to set up recurring tasks and integrate that with my calendar so that I get notifications of things that are coming up and stuff like that. But if you're not so good, or if you want to learn another way of self-organization, I've provided a Gantt chart. Gantt charts are very old. They date back, I believe, to the 19th century. But it's a way of organizing a project with a set number of dates, and then basically the project is due on this date. You work backwards. I need to be doing this on the last day. I need to be doing this on the first day, etc. And we've provided a Gantt chart here. This is on GitHub. I'll go ahead and link to it on the retrospective this week on Piazza. But it's just an Excel file, right? And so, for example, what should you be doing over the last couple of days here? Let me go ahead and zoom. Can I zoom in? Make it a little bit bigger here. There we go. So the project start date here was Monday, 2 days ago. And the first phase of the project, right? Again, it's that standalone assignment that no collaboration. It's got to be your own. You should be reading and understanding the handout in the first 3 days here, right? So if you've already read the handout, great. You're done with that task. Mark it down as 100%, right? Now you see that the color has changed over here, and it tells you that, yes, you're on track. Today is highlighted in red here, and it's automatically updated according to the date on your computer. And you're doing lab 1. So if you are from the this morning section and you're already done with lab, great. You're done with that now. You're on task. You're on time. If you get down here to the 3rd week where it's due on that Friday, and you see a lot of purple here, right? That's a huge indication, red flag, that you are behind, right? But if you want to work ahead and, okay, I've already set up my program, I've already outlined everything because I've seen these programs before, they were from last semester, 155E, and so I'm going to go ahead and mark that as, not that much percent, but 100%, right? There we go, right? It's a way of keeping track of stuff. And I've only outlined what I think I would be doing, right? You can go ahead and go in and customize this thing, and it doesn't take me 3 days to read the handout, right? I could go ahead and start on that on the 25th instead. Right? And now that shifts everything around, right? Because it's all based on, the previous weeks. I like to do my labs early, so I did it yesterday. I'll go ahead and change that to the 24th and shift that forward. I'll always do my labs on Tuesday because I like working ahead or something like that. You can go in and you can customize this however you want. If you're working with a partner, put both of your names on it, right? You're never going to turn this in. I'm not going to look at this. We're not going to monitor this. It is just a way for you to determine, am I on track here, right? Do not start at the last minute. You will fail this course if you start at the last minute, right? And so what should you be doing after you've read the handouts and understood the handouts and done the lab for today? Get started on what you should be doing for the last 2 days of this week. Setting up and outlining your programs. In other words, after lab 1, you've already set up Eclipse, right? Create the classes that you need and stub them out with main functions like we're going to do today for a Hello World program, and get that out of the way. And then start outlining your programs. I know I'm going to need to open up a file and do this thing. I know I'm not going to need to pull this input from the user in order to determine how full the silo is, et cetera, right? And you would know what I'm talking about if you had completed the first task up here of reading the handouts, right? So you can work along here. You'll see here that the weekends are not scheduled for anything. I work on weekends. I don't expect the LAs to work on weekends, and I don't expect you to work on weekends. But if you want to update the chart here to reflect that you do work on weekends, then go ahead and do it, right? Designing your test cases, that's what you should be doing next week. I'm going to also be updating my Gantt chart, my personal Gantt chart here on Piazza throughout the week and throughout the process. All right? So if you want to follow along, great, to know whether or not you're behind or ahead or just on time. If you want to change this so that you're always working ahead, or no, I know that it's not going to, after I get through this first phase here, I know that it's not going to take me a full day to design test cases, 2 days to design test cases here. I'll go ahead and cut that down and change that chart. You get the first few phases for free, right? You got to pay for the last few phases because you'll find out how you work personally, how you and your partner work if you choose to work in a pair. And you can update this as you go along, right? Again, that's available on GitHub. I'll link to it on Piazza later, okay? All right, I don't want to save that. All right, so what we're going to do today is what I had hoped to do at the end of the class last time, but we're going to start on Java. Some of you have already done Lab 1. Some of you did it this morning. Maybe you've read a little bit about it. Maybe you've seen Java before. Great. Java is a class-based object-oriented programming language. What that means is everything in Java is either a class or belongs to a class. Whether or not you're coming from C, which has no classes at all, or Python, which has classes, but you don't have to use them, right? This is going to be a little bit different. In Python and C, when you define a function, my awesome function 001, right? Where does that function live? It just lives out in the global namespace, basically. So if you create a function called myAwesomeFunction001, you've polluted the namespace by putting that function into the global namespace. No other function can be named that thing, right? Unless you separate it out into another module and then not compile to that module or not import that module if you're coming from Python. That's a little bit different in Java in that everything is a class or belongs to a class. You can't just create a function. If you want to create we call them methods in Java. If you want to create a method, you have to put it in a class. So for example, all the math functions that you'll use, sine, cosine, square root, they live in the math class. In Python, you would import the math class and start using the functions because you just imported it. In C, you would just use them after you've included it. But in Java, you actually have to refer to the class, the math class, the square root function in the math class. We'll see that in action later on. Classes, what are they? They're just simply units of code that you are declared and into their own source file. For example, if you've got a class named Hello World, capital H, capital W, it must be in a file named Hello World, same exact name, same exact casing, right? .java. In neither C or Python is that required. You can name your stuff whatever you want. You don't even need to name it .c technically or .py technically. They're just files. But in Java, it's much more restrictive. You have to name it this thing. Let's go ahead and do that. Right? Well, I'm going to go ahead and create, first of all, a new project, a Java project here. If it's your first time doing a project, then this may or may not be there. Otherwise, you could just go project ... and then select what kind of project you want to create. Let me go ahead and create a Java project here for CSCE 156. Right? By default, this little guy down here might be selected. Make sure that it's not selected. Okay? The module system was introduced in something in like Java 9, and it just is going to cause you problems. So get rid of it. It is a nice feature that allows you to do conditional compilation. So if you've got a large, you have a small Java project with that you bring in all these libraries for, you can create smaller, code footprints by only importing what you need, and then when it compiles into a jar file, then it's only what's necessary is in there. Don't worry about that detail. All right. So just make sure that this is not clicked when you create a new project. We walk you through that process in Lab 1 walkthrough, as well as the project setup. Okay? Finish. Done. Great. This, of course, is assuming that you've already installed Java and installed Eclipse on your system, which you'll walk through in Lab 1 if you're using your own machine. It's always an option to use the machines in the lab computers because they've already got everything installed, right? All right, so I've got this SRC file. What do you think that is? Unfortunately, I can't zoom in on the Explorer over here, but that's SRC. So SRC short for source. So the first thing I'm going to do is create a package. And to do that, I'm going to go csc.unl. Actually, no, we're School of Computing now, right? soc.unl, right? soc.unl, that's short for School of Computing.unl, right? What is a package? Well, packages are simply just ways of organizing your code into directories. This is literally a directory on your system. Let me show you. If you right-click and go to Properties, you can open up where that actually is located. There's my CSCE 156 project. Don't want to rename. I've got a bin and an SRC file here. The bin folder doesn't show up here because it's binary. Don't mess with binary, right? You are messing with source code, SRC. Now, if I look over here, what do I see? A directory called SOC. Within that, I've got a subdirectory called UNL. That's what a package is. It's nothing more than directories and subdirectory structure, okay? Now I'm going to create a new class. And because it's our first program in any programming language, what's the first program you always do? Hello world. I'll call it hello world just like I did in the example here. If you want to, you can also click this and it'll automatically generate a main. Right? What is a main? Right? So those of you coming from C will know exactly what a main is. That's where the program starts. Those of you coming from Python, if you just have a standalone script and you just run that script, it starts at the top and starts executing. But I don't know if you did it in Python or not, but you can also in Python define a main. The main, and then within that main function, you can go ahead and call other functions. It is basically the main entry point, where a program starts. A program's got to start somewhere. Where does it start? In the main. Now with this, I can go ahead and zoom in here, okay? Let me just go ahead and get rid of this and print out system.out.println hello world. We'll come back to this in a moment here. Right? For now, I just want to show you how to run it. Well, how do you run a program within an IDE like this, an integrated development environment? You hit play. What did you use in 155A? Did you use PyCharm? Oh, nobody? What did you use? You used the command line? What kind of IDE did you use? Yeah. PowerShell? Oh, okay. From the command line. Oh, wow, okay. What about the Mac users? What did they use? Terminal? Okay. All right, anyway, this is going to be your first introduction to a full IDE. What is it? IDEs are integrated development environments. For Python, a popular one would be, I don't know what IntelliJ's is, but PyCharm is what I hear people use a lot. Right? I use the command line as well. But PyCharm is just like Eclipse over here. It gives you a code editor with syntax highlighting, and it also gives you a way to execute programs. The play button, right? And down here is the output, hello world, right? All right, so source files are compiled to JVM code. What does that mean? Well, in C, if you have a C program, it compiles to machine code. That machine code runs on that machine only for that operating system only. If you want to take your code and move it from my Mac over to your Windows, you need to recompile it from scratch, right? Because it is a different compiler, different operating system, different hardware. What about Python? Python is an interpreted language, right? Once you've written a Python script, it executes anywhere that you have an interpreter on, right? Now, the interpreter itself has to be written for Windows, or the interpreter has to be written for Mac, or it has to be written for Linux. But once you've written one program in Python, you can run it anywhere that you've got a Python interpreter. Same idea with Java here, except that it is actually compiled. It's compiled not to machine code, but Java bytecode. And there's this Java virtual machine that is operating on top of the operating system, and that's what it gets compiled for. It doesn't get compiled for the operating system and the hardware. It gets compiled into Java bytecode. Let's go back over here and take a look at what it looks like. Right? SOC, UNL, hello world.class. That's the binary file that it's been compiled into. Now, if I were to open that up, I would see a combination of plain old English. I'd probably see hello world, but a lot of it would be just Java bytecode, bunch of binary code, right? Even with Python, you still have a JIT, a just-in-time compiler, JIT. And so you might have seen before when you the first time that you run a Python script, there's this underscore pi, whatever it is, right? That's actually your Python script that's been compiled in the background that you never even see, and it's all opaque to you. You never even see that bytecode because it's doing it so that the next time you run it, it's more efficient. It doesn't have to. It compiled it directly for that system, probably. Right. All right. So packages provide organization of your classes. All right. You can use this IDE. We're not going to be using the command line arguments at all, but you can do that with Java, but we're not going to. Let's take a look at our first program here. First of all, I want to add something before we go line by line here. I want to add author documentation. Right? Author documentation in many programming languages, many C-style programming languages, is going to be in a comment with is that a forward slash or a backslash, by the way? Why is it a forward slash? How can you remember the difference? You read left to right. So if a guy is facing this way, are they leaning forward or are they leaning back? Right? This is a forward slash. In fact, you have comments, right? Single line comments, multiple line comments, right? I can go down and slash star. That might be different from your experiences in Python. In Python, how do you do comments? What's that called? The pound sign or the hash, whatever, right? Not the same in Java. Instead, single line comments are forward slash forward slash. Multi-line comments are forward slash star, and then they end with a star forward slash. And then there's a very special type of comment. It's just a multi-line comment, but it is, if you start it with a forward slash star star and then hit enter, it'll go into this blue mode here, right? It's just syntax highlighting, where you can provide some documentation. The minimum of documentation on your first assignment is going to be author, date, and purpose, just like from 155E, right? Who wrote this program? I did. When did you write it? I wrote it, what is today? The 25th. Right? Oops, 2023, 01/23. Right? By the way, that is the only correct way of writing dates. Why? Year, month, and day. Americans get it wrong. Why? Because it's not lexicographically orderable. Right? This is an ISO 8601 standard. Europeans get it wrong, putting the month first, right? The only people that get the dates correctly are computer scientists. Why? Because this ends up being lexicographically orderable. If you have a bunch of dates as a string and you order them lexicographically, right? You just like dot sort or something like that. Everything is in chronological order, right? It doesn't work with the European or the American way of doing it, right? What's the purpose of this program? This is a basic hello world program, right? It doesn't get much simpler than that. But with your programs, you need to provide a good English description of that program. Later on, when you get into your project, what needs to be documented? Every class needs to be documented. Every non-trivial function needs to be documented. Okay? Those are the rules for documentation, or the guidelines for this course. Right? Why do we use this doc-style comment? Because if you hover over this, you'll see that it's actually formatted that way. Right? And what you can do is you can actually interleave other highlighting within this stuff, right? So you can write basic code like this, and the code. You can link to stuff using, say, HTML, or darn it, I was going to ask you what this is. What is this? That's HTML, right? So let's go ahead and link over here to stuff using HTML corn hacks. Corn hacks. Yay. All right. And when you hover over this, you'll see that it's kind of hard to see and I can't zoom in on it. But you'll see that the code has been marked up in monotype, right? Just like code is, right? What about that link right there? It becomes a hyperlink, and you can actually link to it. All it's going to do is open up in the background here what I already had open. Right? You can get really sophisticated with this, and you'll find that all the Java documentation that you'll what functions are in the math library, what methods are in the math library. Well, you'll go and do a Google search, and up will pop a web page. How did they generate that web page? All they did was run a tool, and it generated it automatically based on the embedded documentation here. Right? Obviously, you wouldn't put garbage like this. We call that cruft, unnecessary clutter. So you would get rid of that in your actual final submission. I'll keep it here just as an example. If you know HTML, great. If you don't, you're not going to have need to actually link to anything, at least in this course. All right, now let's go ahead and start at the top. What do you see there? A package declaration. Remember that we put it in the soc.unl package? If that package declaration is not there, right, then it's going to be a compiler error. Let me go ahead and show you. Right? Now it's complaining about it over here because there's a compiler error. The package declared does not match the package soc.unl. So that package declaration has to be there. Later on, we'll take a look about how to bring in external libraries. Those of you from C, you use include and then hash include and then whatever header file you're bringing in. What about you folks from Python? How do you bring in an external library? Oh, no? Import, right? Import, well, like a pprint is one that I always bring in. P stands for pretty print, right? How do you pretty print stuff? How do you, in a nice formatted manner? It doesn't work here because, of course, this is Java. I'll show you that later in Java, though. All right, everything in Java is a class or belongs to a class. And so, therefore, this is a class. It is a public class, and then whatever you want to call your class. Again, if you misspell it, right, then, and it does not match the source file over here, it is a compiler error. Right? Generally, you use upper camel casing. Right? So let's note that over here in our notes. Let's see. And by the way, you're going to immediately ask, where are the notes? They are pushed out to GitHub on a daily or weekly basis. And I will show you where the link is in this week's Piazza retrospective. Right? So observations. Right? So in Java, all class names should be upper camel cased. Right? So if it's multiple words, then the first letter of each word is uppercase, all of the rest are lowercase. No underscores, no names. From Python folks, what is the Pythonic way of naming variables and classes and functions? Oh no? In Python? What should it be? Lower underscore casing, right? And old school C would also do that, but I didn't take that track here last semester, right? So this is just a guideline, right? I'm emphasizing the word should, right? It doesn't have to be that way. You can create classes with arbitrary names. Not arbitrary names, but not following that convention. That ain't the Java way of doing it, just like it ain't the Pythonic way of doing it, and I've had to really work against my drive to use modern casing conventions when I do my Python. I think I went back to all the Python versions of the labs. I think I went back and fixed all of my styling issues because it's just conformity, right? What else do you see here, right? Public static void main. Without a main, there is no program, right? All programs have to have a main somewhere where they begin, right? And what are we doing here? What do you think this line does? It prints something out. What does it print? Well, what's this thing right here? Double quotes. It's a string. Same thing in C, same thing in Python, right? Except in Python, what is the preferred way of doing things? Usually what? Single quotes? Right? That doesn't work in Java, does it? Single quotes in C are what? Single quotes are single characters, right? In C, in Java, double quotes, all right, just one double quote. One double quote, closing a double quote, that's a string, right? So it prints out a string. Well, okay, so from C, or from Python, we just have print, and it automatically puts in an endline character for you. From C, we have printf, and you're responsible for putting in the endline character if you want it. If I just have print here, what do you think the behavior is? Python folks, make a guess. It does not go to the next line. You'll see the cursor there blinking at the end of the D, right? There is no next line. What do you think that the ln did for me? It did put in that end line character. If I hit play, you'll see that the cursor is now on the next line, right? What do you think system.out is? Well, system is a class. Why? Because in Java, everything is a class or it belongs to a class. So the system is a special class that has this member variable called out. What do you think the out stands for? The standard output. What is the standard output? Well, with respect to Eclipse here, it is your console. What's the standard input? Your keyboard. When you mash the keyboard for standard input, that's your standard input. And yes, there is a system.in. We're not going to use it that much. Right? All right, so we've got our first Hello World program here that prints out Hello World. Great. Right? Let's make some more observations. Right? Actually, before we do that, let me go ahead and cut and paste this and show you that I will indeed include most code as Java embedded in the notes here. If it's a major file, I'll only do code snippets like this. If it's a major file, I will, of course, go ahead and check that file into the repository as well. Right? So first of all, my first observation is comments. Right? So comments. What is the purpose of comments, first of all? Comments are for what? Documentation, right? Style comments. Right? You can use slash dot 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 and then slash star slash, right? Multi-line comments are going to be just a single slash star and then end with a star slash. What about a single line comment? Right? Slash slash, right? Forward slash forward slash. Tell me, is this a good comment? We'll print out hello world to the standard output. Is that a good comment? No, why? What, assuming that you're now 3 weeks into the course, say, in the future, right? And you know a little bit, you know enough of Java to read that first line, line 21 there. You know what it does. This is what we call cruft, right? It is cruft. Unnecessary clutter. This is a terrible comment. You should not have line-by-line comments. You only need to document important stuff. The why did you do this, right? What is this? Plain old English stuff like, oh, that's a basic Hello World program, right? If you go A plus B, and we'll get into math here in a moment, right? But if you go A plus B, you know what that is. It's addition. Do I have to put in a comment that says add A to B, right? No, right? That's cruft. That's unnecessary stuff. If you're, if you remember what cruft was from last semester from 155E, or if you're new here, I'll explain it again. The folklore goes, I think it's either at Harvard or Stanford or one of the Ivy Leaguers. Basically, there was this Cruft Hall. I don't know who it was named for, but it was a disused building. And basically, if you had stuff that you wanted to get rid of but you couldn't throw away, like old overhead projectors, old computers, or something like that, you stuffed it in Cruft Hall until it filled up with garbage, and it was just garbage that needed to be got rid of. Right? Well, somebody might have a use for that overhead projector someday with the broken lamp, right? It's clutter. It's hoarding. Don't do it. Get rid of stuff like that. Right? This is good documentation. This is demo documentation that you shouldn't have. Right? If you have a very complex, like these 10 lines of code that are really complex because it's using some convolution method, whatever, then you do document that and say, I'm using Simpson's rule to do X, Y, Z because it has a good convergence property. Here, see this link for more information, right? If you're using some complicated piece of code that needs to, you need to have the documentation of why, right? But single line comments like that should not be there. Code should be self-documenting, right? So avoid cruft. avoid cruft, right? Code should be self-documenting, right? There we go. What else did you notice about this? Whether or not you're coming from a C or a Java background. What's at the end of that line? Semicolon. That's C-style syntax. Do you have to do that in Python? No. So in Java, you do, right? All executable lines of code end with a semicolon. Right. What else did you notice? I noticed opening brackets and closing curly brackets. Do you do that in Python? No. Instead, what do you have to rely on? Spaces, and cross your finger that they're all correct, right? Because if you use 4 spaces on one line and a tab on another line, they look exactly the same, but they ain't, right? So we don't have that problem here. Code blocks are denoted with opening and closing curly brackets, right? So opening, closing curly brackets, dot, 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 right? That ellipsis there is just there's something in there, right? Some people don't know what ellipses are, but it's just like there's something over here. There's here's where it starts. Here's where it ends. There's something in the middle, right? What else? What else do we see? We see basic keywords here being highlighted in magenta: public, static, void. We'll talk about those later, right? But what else do you see? Those of you coming from a Python background, right? Let me go ahead and get rid of all the white space. That's more Pythonic now, isn't it? Except it's terrible because we've got some, it's actually not even Pythonic because if you have Python and you have a if statement, you still indent, right? Well, indentation generally doesn't matter, but it does matter for style. I've screwed everything up, right? I've had, say, space, space here, maybe a tab, tab there, maybe a space, space, space there. Okay, it's screwed up beyond all repair here, is it? Nope. IDE magic, integrated development environment magic, all fixed, right? What did I do there? Let me undo that, undo, 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 undo. There we go. We'll go all the way back over here, and with a very simple one keystroke. Well, first of all, if you just start typing and hit enter, it'll automatically indent for you and indent properly. But if you screw it up and want to go back and just fix it, Mac users, Shift, Command, F, F for format. Right? Windows users, don't quote me on it, but I think it's Control, Shift, F for format. Right? We go through that in Lab 1, by the way. Right? Styling is important. It is worth not a huge amount, but it is worth points on every single one of your assignments. Right? All you have to do is just let it do it for you, and then get in the good habit of always indenting and doing correct indentation. Indentation is important for style, but otherwise white space is ignored. Except, of course, for when it does, it's not ignored. You can't have 2 words together because that would be a different variable name or something. All right. All right. Well, one thing that's different from let's make some observations on differences here. We'll get to this later on, but those of you coming from a C background, there is no malloc, there is no free, there is no memory management, right? You don't have to worry about any of that stuff. You don't have to worry about null terminating characters in your strings. Why? Because Java takes care of all of that for you. Those of you coming from a Python background, same thing. Python took care of all that for you. When you dynamically allocate something from memory, you don't have to worry about whether or not you're cleaning that memory up after you've created it. Python takes care of everything for you, right? It's all opaque. It has what's called automatic garbage collection, just like Python, right? You don't have to worry about it. It's taken care of for you. When a chunk of memory is no longer being used by your program, in C, you're forced to go in and free it up. Otherwise, you've got what's called a memory leak. In Python and Java, you don't have to worry about it. Java is portable. You only have to write it once, compile it once, and you can run it anywhere. That is certainly not true for C. And in Python, you can write it once, but you don't compile it. You just start running it on an interpreter. Right? It's also backwards compatible for the most part. I'm sure I would be flabbergasted if you covered Python 2, right? Did you? Or even wasted time on the differences, since Python 2 is, I think it really reached even the support end of life on support for Python 2. Is that right? I don't know. Anyway, Python 3, it's not backwards compatible, right? Python 3 is the standard, and if you write some stuff in Python 2, it will not necessarily run on Python 3. If you wrote some stuff in Java 1 15, 20 years ago, it will still run today on Java virtual machines. If you wrote something in C 30, 40 years ago, if you recompile it, then it'll still run on today's computers. But with Java, if you compiled it 20, 30 years ago, I think we're in the 27th year, 1995, so what would that be? 27 years old now, right? If you wrote something and compiled it 27 years ago, it will still run today. To a fault, Java has bent over backwards to be backwards compatible, right? Including a bunch of warts and a bunch of bad design stuff that made it into early versions. We're still living with that today because of the design principle that it needs to be backwards compatible. That's not true of, certainly not true of Python, certainly not true of other languages, like PHP is even worse. But hopefully with Python 3, they will be backwards compatible going forward. But otherwise, those are some of the main major differences. Let's jump right into variables. Right? Looks like, yeah, the live stream's kind of weak. I don't know why. But hopefully it's not too choppy for those at home, the massive audience of 5 people watching. But anyway, we've only dropped like 4% of frames, so OBS is reporting that it's okay. Right? That's what happens when you broadcast at 1080p. Right? All right, so what is Java? Java is what's called statically typed. Those of you coming from a C background will understand this. Those of you coming from a Java background, it's going to be new, right? All variables and their types must be declared before you use them. If you're coming from Python and you want to create, and if you want to use a variable, you just start using it. X is equal to 42, right? That doesn't work in C or Java. All right, let me go ahead and create a new class here called demo, and let's create a public method on that, right? And I'm just going to use this as a demonstration purposes, right? So if you want to create an integer in Python, you would do something like x is equal to 42, right? If you want to create a floating point number in Python, y is equal to 3.14159. That doesn't work in this language. That doesn't work in Java. You can see right now that it's giving you a compiler error. If you want to create a variable, you need to declare it and say that this is an integer variable that has a value of 46. If you want to create a floating point number, we call those doubles, right? Double y is equal to 3.14159. Over here, the compiler errors have gone away, but now we've got compiler warnings. If you can't read it, it says that the value of the local variable x is never used. So let's do something with it. Let's print it out. System.out.println. Well, if I could print hello world before, what do you think I can print now? X. I can also print out y. And because I ended those with ln, short for line, they're going to be printed out on their own lines. Yes. There we go. 42 and 3.14159. 15, yeah, I got it right. There we go. All right. What other kind of variables are in Python? Strings, right? So message is equal to hello world, or let's go goodbye world. Goodbye world. You'd be able to store a string in whatever variable you want, right? In Java, not the same. You need to say that this is a string so that I can assign it a string. And by the way, those of you coming from a C background, so much better, right? Why? It's not a character, under the hood it's a character array, but from our perspective, it's not a character array, right? There is no null terminating character, no memory to set up, no malloc to call. It's just a string, period, right? So there are the 3 basic types that we'll cover for now, okay? If you want to print out that message, then print out the message. There we go. Yay, there we go. What about formatted output? Formatted output. So what I mean by that is, those coming from a C background, I mean printf. If I want to print something in a formatted manner, how do I print an integer? What's the format for an integer? %d. Percent is a placeholder, right? It's going to, D stands for not double. Don't ask me why, it's decimal or digit or something like that. It's for integer values. What about floating point values? X is equal to this, and Y is equal to %f. That one makes sense. If you call them floating point numbers, it doesn't make sense if you're only referring them to D doubles, right? And then finally, what's the placeholder for a string? %, that one makes sense, %s, right? And I'll end the line here now because it's printf, right? If you were doing this in C, this would work perfectly, right? It doesn't work in C because, or it doesn't work in Java because, again, what's the mantra? Everything is a class or belongs to a class. That printf function belongs to a class. What class? System.out.printf. There we go. Cut, paste all of your knowledge about printf and put it over here into Java, right? Those of you coming from a Python background, how would you have done this instead? Oh God, I hope that they covered formatted strings, F strings. No? All right, well then here's a Python, something that you should have learned in Python. Here's S is equal to F, and then you make a string, and if you want to print a variable name, what do you do with it? You put it into curly brackets here, right? And if you want to specify a type, it's the same exact placeholders as printf. Y is equal to, I want to print out Y. Just leaving it alone is probably good enough, but if you want to do things like only print it out to 2 decimals of accuracy, you do something like this. And then finally, if you want to print message, that's just a string, so you would print something like this. You'd put that into a string, and then you would print the string, right? Never saw F strings in 155A? You did. Okay, thank God. All right. All right. All right. Cut, paste your knowledge for that here, right? What about if I wanted to change this to, say, money? 0.2F. There it is. 2 decimals of accuracy, right? And it only prints out 3.14 instead of 3.14159. What if I wanted 3 decimals of accuracy? What do you think it's going to do? 3.141? No, 2. Why? Because it rounded. It only rounded for the purposes of printing. It did not change the variable value. Just printing something doesn't change anything. It just, except for the standard output. Right? You can do other tricks like this. 10. What's that going to do? Print out at least 10 columns. So that 42 is going to be over to the left, to the right, by 8 columns. Why? 4 and 2, that's 2 columns right there. And then you wanted to print a minimum of 10 columns. Well, if 2 have been printed already, then that leaves 8 columns to be printed. And it's padded out with a bunch of spaces. If you want to put a 0 in front of it, you can format an NUID with leading zeros. Cool, right? If you wanted to print out this string, but you wanted at least, I don't know, 100 columns, that goodbye world is going to be way over there. All right, it's going to be right justified by default. If you want it to be left justified, what do? Negative. And now it's going to print out hello world or goodbye world like before, but I guarantee you that there are going to be dozens and dozens of spaces over here just that you can't see. All right, questions on formatted output? Otherwise, if you've seen F strings before, but maybe not modifiers, that's okay. This is all you're going to need, right? Dot, and then you can also put like 10 in front of that, and that will print out at least 10 spaces. Remember that the period counts as a space. So 3.142, that's 5 right there. And if you wanted a minimum of 10, that means that there are 1, 2, 3, 4, 5 spaces out front here. Why would you want to do this? Because if you're printing out a bunch of columns of numbers, you want all those periods to line up, right? Just like a ledger. Okay. Here we go. Variables and variable basics. Let's see, Java. All right. So let's conclude on operators. Oops, where is it? Okay, well, let's come over here. All right. I'll keep those 3 same variables there. Actually, let me add some more here. A is equal to 42. Let's create another one equal to 101. Let's go ahead and create another double z, or let's go ahead and change this from x and y. And I'll make this into 10 like that, all right? So assigning an integer to a double is perfectly fine, right? Because 10 becomes 10.0. Assigning a double to an integer, is that going to work? 42.5. That's a floating point number. Can you put that into an integer? In C you can, but what happens? What happens to that 0.5? Truncated, chopped off, and thrown away. It becomes 42. It doesn't even let you do that in Java. It says, wait a second, do you really want to do this? You're losing that precision, type mismatch. You cannot convert from a double to an integer. That's okay. If you really wanted to do it, you could force the issue, but that's not that's not going to work either. Oh, it's because I need to force it to become an integer. There. That's called typecasting. We'll talk about that later. Right? But otherwise, assign integers to integers, doubles to doubles, strings to strings. Anything else doesn't work. Right? But you can do basic math. So what if I wanted the sum of A and B? C is equal to A plus B. Right? So that's a sum. What other operations are there? Let me go ahead and get rid of that. What can I do? I could take the difference. What other grade school math? I'm just asking you to do grade school math now, right? A divided by B. Oops. Let me go ahead and make this into 10 and 20. All right, there we go. And let's go ahead and hold off on division here for a second. What is multiplication in both languages? Python, Java, and C. X. No. Star. There we go. Right? That's multiplication. What about division? It's that two dots with a slash through it, right? Nope. We don't have that on our QWERTY keyboard. Right? What do we have instead that approximates that? Slash. Is that a forward slash or a backslash? That's a forward slash. Good. Right? Let's go ahead and find out what the result is. System.out.println C. Right? Now I'm only printing out one thing, so it should be abundantly clear what C becomes. Those of you coming from a C background, tell me. 10 divided by 20 is what?
Oh wait, it's
Yeah, it's 0. It's half if you were in math class. It is 0.5 if you were in Python class, but it ain't here. It's 0. Why? 10 divided by 20 is 0.5. But an integer divided by an integer is always going to be an integer, right? So what happens? Truncates it. Those of you coming from a C background, how do you get that? Or a C background, Python background, how do you get that? If you were in Python right now, the result of line 16 would be 0.5. How do you get it to be 0 to match what you would expect in Java and C? You saw that, right? That's Python. That's integer division, right? That's not the default division, right? So be careful, integer truncation, right? So how do we solve that problem? Well, first of all, we need a double instead. Z is equal to A divided by B. Let's go ahead and see if that solves our issue here in the last 2 minutes. Is it?
You didn't switch it from print to C.
Oh, sorry. Thank you. All right. Is that going to solve our problem? It's still going to be 0.0. Why? Because an integer divided by an integer is an integer, period. All right? So if you want to divide an integer by an integer and get a fractional result, what do you need to do? You need to force one of them, at least one of them, to become a double. That's called typecasting. You don't have to do that in Python because it's all automatic. All right? One last thing that I'll show you here with 1 minute. Let me go ahead and create an integer really big. Right? Big. So in Python, what can you do with integers? You can sit there and mash the keyboard all day long. Is that going to work in Python? Yes. All right? Python has a native support for arbitrary precision integers. Is that going to work in Java there, do you think?
No.
Nope. We'll talk about that on Friday. Okay?
Is it the same as C with bit size?
Yes, it's exactly the same as C.